Hello students, welcome to the session on Environmental Science. I am Shailendra Darekar, Assistant Professor at AISSMS College of Hotel Management and Catering Technology. Before beginning the new session, let us revise the previous session in which we have learned what is food resource, what is food sources, different types of food supply, world food problems, types of nutrition, what is overgrazing, different types of agriculture, effect of agriculture and overgrazing, waterlogging, salinity, world problems related to food and environmental concerns, and last, food security. Now let us see what are the objectives of today's session. In today's session, we will learn water resource, sustainable management of water resource. We will learn about surface water and we will learn about groundwater. Let's begin. Water is often described as a lifeblood of our planet. It is an essential resource for all the forms of life, playing critical role in various ecosystems, agriculture, industry and human health. Water is vital for survival. Key components of ecosystems, foundation of agriculture, sources of energy, essential for human health. Now let us see why it is important water as a resource. Water contributes a lot in various areas of human activity. First point, essential for life. Water is fundamental to life on earth. All the living organisms, from microscopic bacteria to massive blue whale, require water to survive. It's involved in countless biological processes, including digestion, circulation, and temperature regulation. Second point, ecosystem support. Water sustains diverse ecosystems from freshwater lake, rivers, ocean and wetland. This ecosystem provide essential services such as water filtration, flood control, habitat for wildlife and recreational opportunities. Healthy ecosystem depend on a reliable supply of clean water. Third point, agriculture. Agriculture is the largest consumption of water globally, accounting for around 70% of freshwater withdrawals. Water is essential for irrigation crops, sustain livestock, and processing food. Efficient water management in agriculture is crucial for food security and sustainable development. Fourth point, industry. Water is used in various industries processes, including manufacturing, energy production, and mining. It is used for cooling, cleaning, transportation of material, and as a solvent in chemical reactions. Industry accounts for a significant portion of water consumption globally, and water efficiency measures are increasingly important for sustainable industry practice. Human consumption. Access to clean drinking water is a basic human right and essential for public health. However, millions of people around the world lack access to safe drinking water and adequate sanitization, leading to waterborne disease and other health problems. Ensuring universal access to clean water and sanitation is a key global development goal. Let us understand sustainable management of water resource. It is essential to meet current and future needs while preserving the health of ecosystem and ensuring equitable access for all. Let us see some strategies and principles which can be adopted for sustainable management of water resource. First point, integrated water resource management. Second, water conservation and efficiency. Pollution control and water quality management. Fourth, ecosystem protection and restoration. Fifth point, climate change adaptation. Sixth point, public participation and stakeholder involvement. 7. Policy and governance. 8 point, collaboration amongst governments along with the communities and stakeholders at local, national and global level. Now let us understand what is surface water and groundwater. So surface water and groundwater are two primary components of hydrological cycle, but they differ in their location, behavior and accessibility. Let's define what is surface water. Surface water refers to water that is visible on the earth's surface in the form of rivers, streams, lakes, ponds and wetland sources. It originates from perceptions such as rain and snow melt, which accumulate on the land surface and eventually flow into water bodies or penetrate into the ground. Accessibility of surface water. Surface water is relatively easy to access and utilize for various purposes, including drinking water supply, irrigation, industrial process, navigation and recreation. Surface water is a water that exists above the surface of the earth, include ocean, rivers, lakes, ponds and streams. It plays a vital role in the earth hydrological cycle. Surface water is consistently in motion, flowing downhill under the influence of gravity. It is replenished through perception such as rain and snowfall. Surface water is essential for various purposes, including drinking water supply, irrigation, industrial use and recreational activity. Rivers are natural channels that transport surface water from higher elevation to lower elevation, eventually reach the ocean. Some of the key points in surface water management. Lake and ponds are bodies of standing surface water, often formed by natural process like glaciation or tectonic activity. Surface water quality can be affected by pollution from various sources, including industrial runoff, agriculture chemicals, and untreated sewage. Wetlands are areas where the land is saturated with surface water, supporting unique ecosystem and providing important habitat for wildlife. Surface water management involves various strategies to ensure sustainable use and protection of this resource, including watershed management, water conservation, and pollution control measures. Climatic change is impacting surface water system, leading to alteration in perception patterns, increasing evaporation rate, and changes in stream flow dynamics. Surface water resources are finite and vulnerable to depletion and degradation, highlighting the need for responsible stewardship and conservation efforts. Human activities such as dam construction, land development, and deforestation can significantly alter the natural flow and quality of surface water system. Surface water bodies are interconnected through a complex network of rivers, streams, and groundwater system, forming a dynamic hydrological content. Surface water ecosystems support diverse flora and fauna adapted to aquatic environments, including fish, amphibians, and aquatic plants. The health of surface water ecosystem is closely linked to overall environmental health and biodiversity conservation efforts. Surface water can be subject to legal regulation and management policies aimed at protecting water rights, preventing pollution, and ensuring equitable access to water resource. Surface water availability varies dimensionally, influenced by factors such as climate, topography, and land use pattern. Surface water management often involve collaborative effort among government, communities, and stakeholders to address competing demands and conflict over water resource. Monitoring and assessment program are essential for evaluating the status and trends of surface water quality and quantity, informing management decision and policy formulation. Integrated water resource management approaches aim to balance the competing needs of various stakeholders while safeguarding the sustainability of surface water system. Emerging technology such as remote sensing, geographic information system, and hydrological modeling play an increasingly important role in understanding and managing surface water resource. Sustainable development practices seek to promote responsible utilization of surface water resource while minimizing negative impact of environment and future generation. Now let us see what is groundwater. Groundwater refers to water that is found beneath the earth's surface in porous rock formation, soils, and aquifers. Sources. Groundwater primarily originated from perception that break into the soil and seep into downwards. Accessibility. Access groundwater typically require drilling well into aquifers to extract water. Groundwater is a vital source of drinking water for many communities and serves as a reliable supply for agriculture, industry, and municipal use. However, over extraction or contamination of groundwater can lead to depletion and degradation of this important resource. Let us see some key points of groundwater. Groundwater refers to water located beneath the earth's surface in soil or space and in the fractures of rock formations. It is a crucial component of the earth hydrological cycle alongside surface water. Groundwater can be found at various depths within the earth, from shallow aquifers close to the surface to deep tanks thousands of meters below the ground. Aquifers are underground layers of permeable rocks or sediments that contain and transmit groundwater. Groundwater recharge occurs when the rain breaks into the ground and replenish aquifers, balancing out the natural discharge of groundwater. Groundwater provides a significant portion of the world drinking water supply, particularly in the region where surface water sources are scarce or unreliable. It is also sustain ecosystem by feeding springs, wetland, and stream during dry period. The quality of groundwater is influenced by geological, hydrological, and various other factors, including the type of rock or sediments through which its flow and the human activities such as agriculture and industry. Groundwater contamination can occur from various sources, including chemical spills, leaking underground storage tank, and improper disposal of waste. Overexploitation of groundwater resource through excessive pumping can lead to aquifer reduction, land subsidence, and salt water intrusion in coastal area. Groundwater levels fluctuate seasonally and in response to change in perception, recharge rate, and pumping rate. Groundwater flow pattern can be complex and influenced by factors such as topography, geology, and hydraulic conductivity of the subsurface material. Groundwater modeling is used to stimulate and predict the movement of groundwater within the aquifer system, aiding in water resource management and decision making. Groundwater sustainability requires careful management to balance withdrawals with recharge rate, preventing depletion and maintaining ecological integrity. Groundwater dependent ecosystems rely on the consistent supply of groundwater to support vegetation, wildlife, and ecological process. Groundwater management strategy include groundwater monitoring, aquifer recharge, water conservation measures, and regulation of pumping rates. Groundwater contamination remediation efforts may involve techniques such as groundwater extraction and treatment, soil vapor extraction, and in situ bioremediation. Groundwater pollution can have far-reaching environmental and public health impact, highlighting the importance of preventing contamination and safeguarding groundwater quality. Groundwater governance involves legal frameworks, regulations, and institutional mechanisms for managing and protecting groundwater resources at local, regional, and national level. Groundwater sustainability is increasingly recognized as a global challenge requiring coordinated efforts to address water scarcity, pollution, and climate change impact. Groundwater play a vital role in agriculture, providing irrigation water for crops in many regions and around the world. Groundwater level can be influenced by human activity such as land use changes, urbanization, and groundwater pumping for irrigation, industry, and domestic use. Groundwater conservation efforts aim to reduce water wastage, improve water use efficiency, and promote sustainable groundwater management practice. Groundwater recharge enhancement technique include artificial recharge through injection wells, infiltration basins, and spreading grounds, as well as land use practices that enhance natural recharge processes. Groundwater is inherently connected to surface water system through interaction such as groundwater discharge to river and lake and surface water infiltration to replenish aquifers. Sustainable groundwater management requires a holistic approach that considers the interconnectedness of groundwater with surface water, ecosystem, and human activity. Let us recap what we learned in today's session. We have learned water as a resource. We see sustainable management of water resource. We have learned about surface water. We have learned about groundwater and some key points in groundwater management. Thank you.